Alright, what's up, Precal peeps? As we continue to talk about solving these trig equations, we're going to today hit some trig equations that are going to have squares in them or something that they're already factored. Okay, we'll talk about what that means here as we go. But I want to take a look at the very first one. If you look at this one and we compare it to what we did today in class, I want you to notice got a difference. It's got a square on it, so we're going to have to address that. But for right now, we're going to treat this just like with the ones we did yesterday. We want to try to get this trig equation, this trig function by itself. So what's the first thing we should do? Well, we want to undo the subtraction, so we're going to have to add 1 to both sides. And that's going to give us 3 tangent squared x equals 1. Okay, what should we do next? Again, we're trying to get to this x. Trying to get to that x means I got to get rid of everything else. So next I should divide by 3. And so we get tangent squared equals, or tangent squared of x equals 1/3. Remember, tangent squared is not something we can look up. We're going to need our trig formula charts again, our trig ratios, and all of our different values here. I have tangent, but I don't have tangent squared. So if I want to just have tangent, I'm going to have to take the square root. Okay. Now there's a couple things I want to address about this. First off, when we take a square root, from here on out, on these, we have to put a plus or minus. Okay, so when you take a square root, if you're going to use a square root, a couple things have to happen. First, you have to put plus or minus. Let me explain it all for you on the side. Let's say I want to take the square root of 4. Well, what's the square root of 4? Square root of 4 is 2. But if all you do is tell me that it's 2, you're only half right. Why is the square root of 4 2? Well, the square root of 4 is 2 because 2 times 2 is equal to 4. But remember, also, -2 times -2 is equal to 4. So when we say the square root of 4 is 2, we're only half right. Technically, it can be +2 or -2. So from here on out, if you don't want to have only half the answers, you need to put a plus or minus down. Okay. The second thing I want to talk about is how do I take the square root when there's a fraction involved? We're not going to use our calculators, guys. We're going to take the square root of fraction, we're going to square root numerator and denominator separately. Square root of the numerator and then square root of the denominator. Okay. So if I look at this, I have the square root of 1, right? What's the square root of 1? Well, the square root of 1 is just 1 because 1 times 1 makes 1. And again, technically it's plus or minus. So there, and then the square root of 3. Is square root of 3 a nice thing? No, so I'm just going to leave it as square root of 3. Okay, is this something we can look up or is there something we need to do with this? Well, nowhere on my formula chart do I have just a square root of 3 in a denominator. So remember, these are the types of problems that we need to rationalize. Okay? So we're going to go to tangent of x equals plus or minus. This becomes square root of 3 over 3. Now here's what that means. That means we need to go now look, when does tangent equal positive square root of 3 and when does tangent equal negative square root of 3? Okay, so I'm going to look under tangent and I'm going to look for positive square root of 3, so I know pi over 6 is one of my solutions. Okay, pi over 6, definitely one. But I also want negative square root of 3 over 3. So 5 pi over 6 is another one that I want to keep. Let me move you out of the way. Okay, 5 pi over 6 is another one. And let's see, are there any more? Yep, here's another positive square root of 3 over 3. So 7 pi over 6 is the next one. And And let's see, any other ones? Yeah, right here, 11 pi over 6. So the idea is, main idea, when there's squares involved, you're going to have to square root. Okay, so when you square root, you need to put a plus or minus, and you square root the numerator and denominator separately, and then rationalize if necessary. Okay. So because of this plus or minus, this gives us 4 solutions. And again, when you put these into Canvas, you're going to spell out pi, not PIE, just PI. So pi slash 6, comma, then a space, and then 5 pi slash 6, then a comma and a space, 7 pi slash 6, comma and space, 11 pi slash 6. Okay, so you can type in all of those in the blank. Okay, try to get them in order from smallest to biggest. Okay, all right, let's try another one. Okay, here's another one. Again, we should notice there's a square in there, so eventually I'm going to have to get rid of that square by square rooting. But before I do that, I've got to get rid of all this other stuff first. Okay. So what's the first thing I need to do? Start getting this x by itself. I'm going to have to add 2 first, not 4. Okay, I'm going to have to add 2 first to both sides to cancel out the minus 2. So I have 4 cosine squared of x equals 2. Okay, next I need to get rid of that 4, so I'm going to divide by 4. Okay, so cosine squared x equals 2 divided by 4. I know 2 divided by 4 reduces, but I'm going to hold off on reducing because I know I'm not done with my math. Because I still have this square to get rid of. Again, how do I get rid of the square? I get a square root. Okay, automatically. What should I put down? Every time I take a square root, what do I put down automatically now? Plus or minus. Has to be automatic, guys. Anytime you take a square root. We haven't had to do that in the past because we've been dealing with sides of triangles and distances can be negative. So we haven't had to deal with that before. Okay, but we're having to deal with it now because we're talking about a purely mathematical situation. Okay, so again, we square root both sides, we automatically put a plus or minus, and now we square root the top and bottom separately. Okay, square root of 2, well, I can't do anything with that, it's just square root of 2. Okay, square root of 4 is just 2. It's no longer square root of 2, right? Square root of 4 is just 2. So this is what we're doing. We're square rooting both parts separately. Square root of 2, I leave square root of 2 because it can't change. It's not nice. But square root of 4 is 2, and we've already taken care of the plus or minus. So again, look, we're gonna end up looking for, under cosine, positive and negative square root of 2 over 2's. Okay, so let's go find those. All right. So under cosine, we want positive and negative square root of, not square root of 3, square root of 2. So there's the first one, pi over 4. Pi over 4 is our first one. We wanted the negative one also. So 3 pi over 4 is the next one. Okay, not that one, that's a 3. There's another negative square root of 2 over 2, so 5 pi over 4. Okay, let's go down a little bit more. Any more? Yep, there's a positive square root of 2 over 2. We're looking for the positive and the negative because we had to take the square root. Okay, so that's all of them. Again, we want to list them from smallest to biggest. Basically, if you go down this chart, it's already from smallest to biggest. Okay, so you just go down that chart. Again, we're looking for the positive and the negative because we had to take the square root. Okay. All right, now here's the other type that you're going to see today. Okay, take a look at that. Okay, that does not look nice. All right, what does your instinct tell you that you need to do with this? Well, if you remember what we did when we were simplifying, you're probably thinking, man, I need to distribute. Well, here's where you need to tap the brakes on that. Okay? And it's all because of this. Okay, we are not going to distribute we are not going to distribute because this thing equals 0. All right, I want to introduce you to something that you already know, but I'm going to give you a formal definition of it. There's something called a zero product property. You use this in Algebra 2 a little bit, whether you remember it or not, that if I'm multiplying two numbers together, two things together, and I'm supposed to get 0, think about it for a second. I am supposed to be multiplying two things, and I'm supposed to get 0. Well, the only way for that to happen is if either A equals 0 or B equals 0. If one of those two things is 0, this will become a true statement. And so this is called the zero product property. And that's what we're going to use here, and that's why we're not going to distribute. If I distribute this, I'm just going to complicate my life. I already have two things getting multiplied, and the result is supposed to be 0. So that tells me either this thing has to equal 0 or this thing has to equal 0. So that's what we're going to do to solve it. We're going to say 1 minus cosine of x equals 0, and then we're going to say 2 sine of x plus 1 equals 0. And so now it's just two little mini equations like we had yesterday. If you're multiplying and you're supposed to equal 0, don't distribute. Set each factor equal to 0 and solve each one of those. Okay, so let's go through this one. Let's solve this one over here on the left first. How do I get to that cosine? How do I get to that x? Well, first would be get rid of the 1. All right, and that's an addition or subtraction happening here, so it's a positive 1. I'm going to cancel that out with a minus 1. I got negative cosine of x equals negative 1. I don't want negative cosine, I want positive cosine, so I'm going to divide everything by negative 1. And a negative divided by negative is going to make this positive cosine equals 1. Now I'm ready to go look it up. When does cosine equal 1? Let's go look to our formula chart. Okay, we want to go back to our cosine, and now we want to find the 1. Well, there's 1 right away, so 0. Any others? We don't want negative 1. It just said cosine equals 1. So 0 and 2 pi. Well, isn't 2 pi the exact same thing as 0? Remember, 0 and 2 pi are the exact same thing. So I'm just going to put down x equals 0. Okay. Again, you can put down 2 pi, but because it's really the same thing, I don't want to repeat it. I don't need to have it. Okay. All right, now let's solve this one. Same thing. I'm trying to get x by itself, so I need to get rid of everything else. First thing would be get rid of the plus 1 with a minus 1. So now 2 sine of x equals negative 1. All right. Now we divide by 2 to undo the multiplying. And sine of x equals negative 1/2. And now we go look it up. When does sine equal negative 1/2? Okay, let's go to our trig ratio formula chart. We're looking for sine. Again, which one was it? Sine equals negative 1/2. Okay, none there. There's the first one. So 7 pi over 6. 7 pi over 6 and 11 pi over 6. Okay, those are our two solutions that we're going to pull up. 7 pi over 6 and 11 pi over 6. So since 0 solves this part and 7 pi over 6 and 11 pi over 6 solve this part, they are all part of our final solution. 0, 7 pi over 6, and 11 pi over 6. Okay. Again, we could have thrown in the 2 pi, but the 2 pi is the same thing as 0. All right, so that's the deal with these. If you're multiplying and you equal 0, don't distribute, set them equal to 0 and solve each one separately. The ones that turn the answer that turns this into 0 will make this a true statement, and the answers that turn this into 0 will make this a true statement still, right? Because if this part's 0, 0 times anything is still 0. If this part is 0, anything times 0 is still 0. Okay? It's zero product property is amazing. Okay, let's look at one more. Okay, here we have another multiplication happening. Again, don't distribute if it equals 0. Okay, if it equals 0, we are not going to distribute. All right? If it equals 0, we're just going to set each factor equal to 0. So sine of x equals 0, and then 3 tangent of x minus 3 equals 0. If you're multiplying, if you see a multiplication that equals 0, don't distribute. Set each piece equal to 0. Okay, and now let's solve it. Well, this one's already solved. We just got to go look it up. Okay, when does sine equal 0? Let's clear everything out. We're looking in sine. Sine equals 0 right away at 0. And pi and 2 pi, but we're not going to use 2 pi because it's the same thing as 0. Okay, so our answers for this one are going to be 0 and pi. Okay, now let's solve this one. Again, if I want to get to x, I have to undo everything else. So I'm going to add 3 first to undo the subtraction. 3 tangent of x equals 3. Okay, what should I undo next? This 3, the multiplying. How do you undo multiplying? Dividing. So now this says tangent of x equals 1. Again, now we're ready to go. Look it up. Okay, when does tangent equal 1? Okay, let's come back over here. Tangent equals 1 at pi over 4. We don't want that one. That's the negative one. The next one would be, let's see, 5 pi over 4. Okay, pi over 3, what did we say? Pi over 4 and 5 pi over 4. Pi over 4 and 5 pi over 4. Okay, now we got to put these in order. Okay, we got to put them in order. So when I put them in order, 0 should come first. Okay, and the next should be pi over 4. And then next should be pi. And then next would be 5 pi over 4. Okay, this one has 4 answers to it. Again, so that's what we're going to do. If we're multiplying and it equals 0, do not distribute. Set each piece equal to 0. If you have squares, you're going to have to take the square root eventually, but remember to do 2 things. Number 1, put down a plus or minus. Anytime you take a square root, you got to put down a plus or minus. Number 2, you're going to square root the numerator and denominator separately, and that may mean you have to rationalize. Okay? All right, that's it for today. Be ready to work on Monday on some more of these. Come with questions.